I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on mass spectrometry. Before us, a typical chemistry A-level question on mass spectrometry, which is an analytical technique that is used to determine the relative atomic masses of elements and the relative molecular masses of compounds. The mass spectrum of a compound X has M, M+1, and M+2 peaks. Other peaks are also present. Peak M is the molecular ion peak M+. Peak M has a relative abundance 15 times that of peak M+1. Peaks M and M+2 of equal height. What could be compound X? Now we'll have the molecular ion. The molecular ion +1 peak is an indication of the presence of carbon-13 isotope. The presence of molecular ion +2 peak is as a result an indication of the presence of a halogen in that organic compound. Whether it is bromine or chlorine will be determined as we proceed. Now, other peaks are also present. Now, what happened is that the question says peaks M and M+ of equal length. That is an indication that that the compound contains a halogen, and the halogen is bromine. Because if the molecular ion and the molecular ion +2 peak are of equal length, that means the compound contains a bromine atom. It contains a bromine atom. So what we're supposed to do here is to calculate the number of carbon atom. The number of carbon atom as a result of the presence of carbon-13 isotope. Now, we are given that peak M has a relative abundance 15 times of that of peak M+1. So that means if we assume that peak M+1, let's take peak M+1. Let's take peak M+1. M+1, we don't know. Let's assume that peak M+1 is equal to X. That means peak M now, which is the molecular ion peak, will be equal to 15X, which is 15 times X, which is equal to 15X. Now, what you have to do, we have to calculate the number of carbon atoms. So we use the formula, number of carbon atoms is equal to 100 multiplied by the abundance of the molecular ion +1 over 1.1 divided by the abundance of the molecular ion peak. Now, to calculate the number of carbon atoms, and we equal to 100 divided by 1.1 multiplied by abundance of the molecular ion +1 peak is X over the abundance of the molecular ion peak, which is 15X, or 15 times X, which is 15X. So this X counts X here 1, X here 1. So we're going to have I have to use my calculator now. It will be 100 times 1. 100 times 1 is equal to 100 divided by the 1.1 times 15, which is 16.5. So 100 divided by 16.5, let me use my calculator. 100 divided by 16.5, which is 1. Which is 6.06. So it equals to 6.06, which is approximately 6. So the number of carbon atoms here is equal to 6. So we have 6 carbon atoms, and we are given that the molecular ion and the molecular ion +2 peaks are of equal length. So the halogen that is present is is bromine and not chlorine. So A is not the answer. A is out of it. What could be compound S? What could be compound S? So compound S could not be A. A is not the answer because A contains chlorine. B is not the answer because B contains chlorine. So the answer is that the compound X must contain bromine as the halogen, and the number of carbon atoms in that compound must be 6. So let's look at C. Let's examine C, which is 2-bromo-2-methylhexane, which is 1, 2, 3, 4, 5, 6. So 2-bromo. 2-bromo-2-methylhexane. So if we count the number of carbon atoms, you have 1, 2, 3, 4, 5, 6, 7. So C is not the answer. I think the correct answer should be Should be D, but we need to prove it. So 3-bromo-2,2-dimethylbutane. So let's count 1, 2, 3, 4, which is butane. 3 bromo, 1, 2, 3. So bromine will be here. So this is bromine. Then 2, 2 dimethyl. Then you have CH3 here. Then you have CH3 here. So if we are to count the number of carbon atoms, it will be 1, 2, 3, 4, 5, and 6. So the correct answer to this question is what? D, which is 3 bromo, 2, 2 dimethyl butane, because it contains bromine atom, where the molecular ion and the molecular ion plus 2 peaks are of equal height, and the number of carbon atoms is equal to what? 6. So it's as simple as what? A, B, C. Attempt as many questions as possible, and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you for listening, and feel free to reach out to me if you encounter any challenge or any difficulty. Thank you very much. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on mass spectrometry. Before us, a typical chemistry A-level question on mass spectrometry. In the mass spectrum of a compound Z, the relative abundances of the M and M plus 1 peaks are in the ratio 3:1. That is the molecular ion and the molecular ion plus 1 peak. Now, in mass spectrometry, it's an analytical technique that is used to determine the relative atomic masses of elements and the relative molecular masses of organic compounds. Whenever we discover what the molecular ion and the molecular ion plus 1 peak in an organic compound is an indication of the presence of carbon-13 isotope. When you look at the mass spectrum of an organic compound, if there's presence of carbon-13 isotope, there's going to be what? The molecular ion plus 1 peak. So if you look at the peak, the molecular ion peak is the peak that has the highest mass to charge ratio. So if there's presence of carbon-13, there's going to be an additional peak, which is the molecular ion plus 1 peak. So in that situation, we'll have to calculate the number of carbon atoms. So to calculate the number of carbon atoms, we use the formula number of carbon atoms N. Number of carbon atoms N is equal to what? 100 divided by 1.1 multiplied by the abundance of the molecular ion plus 1 peak divided by the abundance of the molecular ion peak. So number of carbon atoms will be equal to what? 100 times abundance of the molecular ion peak is 1 divided by 1.1 divided by what? 13, which is the abundance of the molecular ion peak. So we have to calculate now. It will now be 100. 100 times 1 is 100 divided by 1.1 times 13 is 14.3. 100 divided by 14.3 will be equal to 6.99. 6.99, which is approximately what? 7. So the number of carbon atoms will be equal to what? 7. That means the compound Z must contain 7 carbon atoms. So the correct answer would be the organic compound that contains 7 carbon atoms. So let's analyze the compounds one by one. If we look at A, which is butyl butanoate, butyl butanoate will be C3H7 COO C4H9. So automatically we have 8 carbon atoms here. 4 plus 1, 5, 5 plus 3, 8. So we have 8 carbon atoms here. So butyl butanoate is not the answer. Now let's go to B, which is hexanthraone. From hexanthraone, we have 6 carbon atoms here. So B is not the answer. Hexanthraone is not the answer. Now let's look at C, which is 2,2-trimethylhexane. So let's take it out. 1, 2, 3, 4, 5, 6. So this is 2,2. Yes, CH3. CH3, 223. So this is the third carbon atom, CH3, trimethylhexane. So we have to count the number of carbon atoms. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So here we have 9 carbon atoms. So C is not the answer. C is wrong. C is not the answer. So automatically the correct answer will be D. So we have to prove it. 3,3-dimethyl pentanone odd. So we have 1, 2, 3, 4, 5. Since it's pentanone, or we have OH here,
first carbon atom, second carbon atom, third carbon atom. We'll have CH3 here, then we'll have CH3. So it is 3 dimethyl pentan 1 So we have to count the number of carbon atoms. We have 1, 2, 3, 4, 5, 6, and what? 7. So 3 dimethyl pentan 1 contain 7 carbon atoms. So D is the correct answer. The correct answer is what? D. So it's as simple as what? ABC. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you for listening. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures. So before us, a typical chemistry A-level question on mass spectrometry, Cambridge International Examination A-level question on mass spectrometry. Vitamin C has the structure shown, so you can see the structure of vitamin C. The mass spectrum of vitamin C has a molecular ion peak with an M/E value of 176 and a relative abundance of 7.0%. What is the abundance of the M+1 peak, which is the molecular ion plus 1 peak? Now, if you look at the structure before us, it's an organic compound. Now, when we talk about mass spectrometry, it's an analytical technique that is used to determine the relative atomic masses of elements and the relative molecular mass of organic compound. And in most organic compound, the most common element is carbon, which is an isotope. So we have carbon 12, and carbon 13. Carbon 12 is the most abundant, which is the molecular ion that will always give you the molecular ion. Then carbon 13 is the molecular ion plus 1. So whenever we analyze an organic compound and it contains both carbon 12 and carbon 13, what happens is that on the mass spectrum, the molecular ion peak will always have the highest mass to charge ratio. So if there's presence of carbon 13 in that organic compound, there's going to be an extra peak which occurs as a result of the presence of carbon 13 isotope. That means carbon 13 is present in that organic compound. So it will show an extra peak, which is the molecular ion plus 1 peak closer to the molecular ion. So we need to calculate the number of carbon atoms. So we use this formula. N is equal to 100 divided by 1.1 times the abundance of the molecular ion plus 1 divided by what? Abundance of the molecular ion peak. So the first thing we are going to do is to look at the organic compound, then calculate the number of carbon atoms. So we have to calculate the number of carbon atoms first, so that, and we are given the abundance of the molecular ion peak. The molecular ion peak, the mass to charge ratio is 176, and the relative abundance is 7.0. So the abundance of the molecular ion peak, we already know that it is 7.0%. So what happens? We need to calculate the number of carbon atoms. So if you look at the structure, let's count the number of carbon atoms. So we have 1, 2, 3, 4, then 5 and 6. So the number of carbon atoms equal to 6. So we have 6 carbon atoms. So we have to apply a formula. N is 6 will be equal to what? 100 divided by what? 1.1 multiplied by what? The abundance of the molecular ion plus 1 over the abundance of the molecular ion peak. The molecular ion peak is 7.0. So we want to calculate the abundance of the molecular ion plus 1 peak. So we now have, where to calculate, we now have 6 will be equal to what? 100 molecular ion plus 1 divided by what? 7.7, because 1.1 times 7.0, we have 7.7. So we'll cross multiply. We now have 6 times 7.7. So I'm to use my calculator. 6 times 7.7. 6 times 7.7. You have 46.2. So you have 46.2 will be equal to what? 100 molecular ion plus 1. So to get the molecular ion plus 1, we'll make it the subject to the formula. So molecular ion plus 1 will be equal to what? 46.2 divided by what? 100. So 46.2 divided by 100, use my calculator now. 0.2 divided by 100 will be equal to 0.462, which equals to 0.462%. So the correct answer to this question is what? A, which is what? 0.462%. So it's as simple as what? A, B, C. Attempt as many questions as possible and feel free to reach out to me if you have any difficulty, if you encounter any challenge, any difficulty. I'm always there for you. I'm Mr. Joseph, the chemistry teacher. Thank you for listening.
Subscribe to my YouTube channel, comment, like, share, and reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel. Thank you very much. Mr. Joe, your chemistry teacher.